Hello, my name is James Poinski. We're going to talk today about when Couchbase meets Splunk from a dashboarding perspective. So today's speakers is myself, James Poinski, and my colleague Andrea Vasco, who will drive the demo. So he'll introduce himself when he does the demo. But for me, I've been with Couchbase 4 years, over 4 years now, supporting the Nordic region. So I'm based in Oslo, Norway, and yes, I'm American, but I live in Oslo because my kids are Norwegian and American. So that's the short version of a long story. But before Couchbase, I was a developer doing Android development, mobile development, backends, and then server-side code. And then the first half of my career was doing embedded software as well. So the goal of today's session is to showcase Couchbase from a real-time analytics perspective with continuous intelligence, with the synergy of an industry-leading platform called Splunk. So what is real-time analytics? So Gartner's definition of real-time analytics is the discipline that applies the logic and mathematics to data and provide insights for making better decisions quickly. So in traditional analytics, you'll have an ETL process that's pretty much a cron job or some scheduled data movement as an ETL into another object, another solution. So the real concept behind Couchbase as a data platform is that these analytics are natively inside the database, and so it can be no ETL in NoSQL. So why should anybody be concerned or be interested in this? It's Gartner says that by 2022, more than half of major new businesses will incorporate continuous intelligence and use real-time context to improve their decisions. So this improves the improved quality, precision of operational decisions, and it's basically making more informed decisions. And the impact is basically, it gets data scientists closer to the data instead of looking at it from a delay. It basically could be minutes, hours, basically on how it's scheduled, to being in real time, and it brings the operational and analytics data together. So soon there will be two types of organizations: those who make things happen with data, and those who no longer exist. And we've seen this time and time again. The one company that keeps coming to mind is Sears and Roebuck, that just basically did not evolve, and is ultimately not I don't know if they're not in business or not, but they're pretty close. So continuous ingestion and analytics entities. So Dataverse, top level organization concept, short for Dataverse, data universe, and it's a namespace that gives a place to create and manage data sets and other artifacts. And then we have data sets. So data sets would be in what we consider a data set in Couchbase, contains a whole collections of JSON objects linked to a bucket. And it's similar to tables and key spaces in NoSQL. So how does analytics work? So we have shadow copies of the data service data. So what this means is that we have these on the left side, we have continuous ingestion of these data nodes and the mutations that occur. So the creating and updating of documents within the data set is basically then pushed to these analytic nodes, but it's pushed in what we call DCP, or data change protocol. So this is asynchronous and event-driven architecture. There is no continuous scan of the analytics are not continuously scanning the data set for changes. It's getting notifications that there's changes. And this is why it could be close to real time. So this is where we can say we are close to real time because of this, asynchronous and event-driven architecture. And then we have massive parallel processing, or MPP architecture. So complex queries on large data sets. And we create these basically shadow copies exist as like an index. So you can basically create index. So you're not basically, this analytics service is not really having a shadow of the entire database. So I know that some other databases that support analytics, you have to shadow the entire data set and have a separate entity that's running this. So with the shadow data set, with Couchbase, you don't have to do that. You don't have to shadow the entire data set. You can define it as indexes. In these indexes, this is where queries will work against those indexes. And it could be very broad and ad hoc. So it can be broad, touching many different parts of different types of documents, and then basically collated together. And what this equals is insight, real-time information for business teams. So continuous detection, you have workload isolation, you have separate services running separate nodes. What's happening in analytics does not influence what's happening in data service or in the NICL, for instance. There's performance isolation. There's separate scaling based on needs. So if data set doesn't grow, but your analytics needs grow, you grow just analytics. You don't need new data nodes. It's not necessary. So as I mentioned before, we have parallel shadowing of data sets with data change protocol. We have low impact on data nodes. It's basically the impact is just generating events, and then high data accuracy, and then the M-to-N connectivity. So complex queries and large data sets for, in NICL for analytics. So what basically is that analytics uses SQL++. SQL++ was the created by Don Chamberlain, one of the founders of SQL. It's his vision of SQL plus JSON, and that's why we call it SQL++. NICL is the first commercial implementation of SQL++. We're very close relative, in the 99%. I don't know what the exact value is, but it's very, very close. So so if you know NICL, you'll know SQL++ very easily. But there's also things in SQL++ like multiple range scans within a query. This is very powerful, creating dashboards where you can start to aggregate different range scans and get one result set back, and then within that result set, just render it. We're not doing any kind of post-processing on the application side. And so complex queries and large data sets, we have three different document types. We have rentals. You see all the identities of the actual vehicle. We have the location where that vehicle is located, and we have the rates for that particular location. And so what we're going to see is that, creating analytics data sets, here we go. It's just basically like an index. We have created data set of location on the bucket of rentals where the type is location. And you'll see that it's very reflective. And, basically then you can create these singular indexes, which are not necessarily singular, but they're singular in terms of in this example. And then basically starting the synchronization, operational bucket to analytics data sets is this connect link local. So basically the Dataverse displays remaining mutation. You'll see the mutations are, you'll see the mutations that are remaining mutations for each one of these different buckets. And so complex queries. So here's basically an example of what a complex query, and you notice that there's that embedded, there's embedded SQL happening right away. And this is a power of SQL++ that we have a select star from, but embedded within that, we have a very distinct query against, location, the state, the city, the dollars, and not only taking it from the rentals bucket, but also taking it from locations, rates, and so we can basically dig down very deeply. And then we're doing it basically at the end, we're doing a window function. So we have all this encapsulated one singular query, which is the power of SQL++ plus Couchbase analytics. And so we notice it's subquery, and then the unnested array, and then you have the windowing function at the end. And then you have the results. It's a result set that's collated, that's it's directed, it's collated, and it's basically expressive to what exactly is needed in the application. So introducing Splunk. So Splunk is what we're going to do in this, and Andrea will explain a little further during his demo, but basically Splunk's going to be that endpoint that's going to be a scheduler that's going to do that scheduling itself, no cron jobs needed. Andrea is going to demonstrate how you schedule in Splunk and how you basically can touch Couchbase and pull data out of Couchbase, and show Splunk regular scheduling queries against that, and then rendering it in a dashboard. So Splunk guides customers through a complete data journey. Splunk is originally just thought of as just for statistics against operational view of, or a site reliability engineer's view of statistics. But you can do investigate, you can monitor, you can analyze, and you can act against, in the IT, security, DevOps, and business processes. So the field of play here is basically we have a key value ingestion. We have Andrea's going to set up a ingestion tool that's going to push data into Couchbase. And we're going to watch that data go into Couchbase, and then Splunk basically running a scheduler that's going to then touch Couchbase and say, I need, updates, and then basically bring those in. So you're seeing that there's maybe mutations to Couchbase, the analytics is immediately notified and updated, and then Splunk is within seconds is actually then be able to render the results, which is what the power of real-time analytics is. You're not waiting minutes, you're not waiting, you're in the almost seconds time frame, which is, pretty much when a customer will be still on your website. So here, seeing is believing. And what the key takeaways is Couchbase multidimensional workload scaling and massively parallel processing capabilities. The synergy between data-related solutions is a key to achieve data intelligence. And then you can reuse that NCL now because NCL is just, is very, very close relative to SQL++. So here's a demo, and here's my colleague, Andrea. Thank you.
Thank you, James. And hi, everyone, wherever you are in the world. Thanks for joining us today. My name is Andrea, and I'm a solutions engineer here at Couchbase. I'm based out of London, so I'm in the EMEA market. And yeah, today, in the next 10 minutes or so, I'm going to walk you through a quick demo, right, as to how we can use Couchbase Analytics in conjunction to another tool to provide what Gardner refers to as continuous intelligence. So the ability, right, to operate higher level of BI machine learning over operational data in real time in order to quickly adapt and adjust, right, to the latest trends of what your customers are doing. We chose to use Splunk for a few reasons. First, I have some history with Splunk, so it was a natural choice for me. Back in the day when the wave of big data came in, at least where I used to work, Splunk was probably the solution used to make big data reporting, because the adoption of things like Hadoop and MapReduce was not that widespread. So we chose to, use Splunk. And the other big advantage of Splunk is the machine learning toolkit, right? That it allows us to demonstrate some of the things we want to demonstrate today in an easy way. And it probably will allow you, right, to do the same in case you would like to have a taste of what you can do with the realm of analytics. So let's get started. First and foremost, you should be able to see my screen, and you should be able to see my cluster under one Kenobi. Good name, isn't it? And in our cluster, right, it's essentially mimicking probably a pretty significant large cluster that you may run, right, in your environment. We have 3 nodes for the data, a couple of nodes for all querying and searching services. And we also turn one of them down in order to spice things up and make the point of the multi-dimensional scaling of Couchbase, the isolation of the workloads. And last but not least, let me just sort by services, we have 3 analytics nodes. So as Jamie explained, right, analytics works tightly together with the data service, right, even though they scale independently. But every time you load information within Couchbase, right, the data service kicks in and will store this information into buckets. And then you can use analytics through DCP, right, to create shadow copy of these buckets, either a complete copy or a scaled down copy using where conditions. We're going to see how you can create one in a second. But the idea, right, it's that data will flow through the data service within our KV engine, and you can pull this data through KV calls. And that's arguably the fastest way, right, to access the document within Couchbase. But then if you want to isolate the workloads, you can replicate part of this data within data sets. This is the actual name within the analytics service. And through data sets, right, you can expose this information downstream for big data analytics kind of use cases. So let's look around a little bit about the field of play. If we take a look at the buckets, we're going to use one bucket called CouchMart, right? And here in CouchMart, we're going to have, let me just give you a taste. We have this kind of documents, right? So we are essentially mimicking documents that essentially role play orders. Let's assume we are a store, right? We are, a convenience store, and we have things like if the transaction was approved or declined, the name, the gender information, email, anything we may know about a customer, and of course what the customer actually bought within that transaction. All right. Okay, so this is an example of the information we have. All this information was generated, right? So there is no issue whatsoever with GDPR, and I'm going to show you how you can do that as well, if you wish so, right? One of the ways. And then from the bucket Couchmart, right, we have created, of course, an analytics bucket. We go here, sorry for that. Oh, come on. Yeah, I'll keep on clicking. Sorry for that. There you go. Right. So we already created one data set called Acme orders, right? So if I do select everything from Acme orders, Acme orders, limit 10. Let's make it a little bit faster, right? Don't want to have you hanging, right? Here we have the complete information, right, that we have into Couchmart. There is no filter, anything like that. So if you wanted to create a new bucket, right, a new data set, sorry, it's pretty easy, right? Let me just go back in history. But there you go. You can create something like this, right? Create, this is the syntax, data set. You give the data set a name, Android is the best, on the bucket. And then here, ideally, you can put some more conditions, right? Let's just take easy for the moment, right? But if you execute this, everything you see here, now we have a new Andrea is the best, right? That it's, we're told, right, that the Andrea is the best is connected to the Couchbase bucket Couchmart, and this icon tells me that the replication is already active. If it's not active, just bear in mind that if you issue connect link local, right, this command will eventually, right, make sure that the replication is active. So the idea is that we have this Couchmart bucket, and every time one of our customers makes a transaction, the information will go into Couchmart. Couchmart is then replicated into the analytics bucket called Acme orders, right? Just forget about Android is the best or this one orders, right? Let's stick to Acme orders. And we're going to use Acme orders downstream to feed Mr. Splunk. There you go. So you can see here, we already configured a dashboard within Splunk, a dashboard that has information about the top grossing products, products over time, transaction approval rate on time, number of orders that were fetched. So if you're seeing here a difference between the number of orders that we have here and the number of orders that we have within Couchmart, well, the idea is that for the purpose of this demo, we wanted to play around with different retention. All right, so that's the idea. And then here we are using the machine learning toolkit of Splunk, right, just to derive live information. So we used the machine learning toolkit of Splunk over these 14,000 orders roughly, right, to identify 28 outliers. And you see here, you can have more details about when the outlier was identified, and also a prediction accuracy, right? If here we are just trying to predict if the actual order will be approved or declined, right? Yeah, it's pretty much a coin toss, but it's not surprising in this case because, I mean, all the data is absolutely generated randomically, right? So I wouldn't expect that much more, to be honest with you. All right, so the information with this Splunk, this is the only piece of information I'm going to give to you because it's relevant for setting up your own environment, right? We provide information to Splunk through a script, and the script file, there you go, it's this one right here, right? Nano Acme orders.sh, it's a shell script, and it's probably the easiest thing ever, right? It's a curl call, right? Where we're gonna have the username and the password, and then we are just running a statement, select everything from Acme orders, and then this where condition that seems super complicated, in reality, it's just, hey, where the time of the transaction it's major, then now minus, that should be 3 minutes. So the idea, sorry, 5 minutes. And so the idea, right, is that we are implementing some sort of work condition in order to avoid to keep importing in Splunk the complete data set. In production, of course, you may want to find out the smartest way, right? But ideally, this cruel command, right, it's responding to us with the JSON format, and this JSON format it's then used and crunched and fetched and adjusted within Splunk. So without any further ado, let's try to get things going, and let's try to generate new orders within our application. These orders will be stored into the Couchmart bucket, and let's see, right, this update happening on Splunk. The last thing that I have to say you is that I configured this old dashboard and the fetching of data to happen every 30 seconds, right? So you could use probably eventing, if you will. You can use some sort of callback kind of strategy. I wanted to keep as simple as possible. So here, everything you see is just being refreshed every 30 seconds, right? 30. So how can we create some new information? Well, on our website, you're going to see the mention to a pretty cool tool called Fake It, right? So I didn't want to rinse and repeat something that you may already seen. So we decided to use this other pretty handy tool, right? That is available online. It's called Json Generator. This is pretty cool because it allows us, right, to randomically create JSON information, and that is also a good peace of mind for you if you are concerned about things like the GDPR and so on and so forth. And here through this specification, right, this is JavaScript task, if you will, we are essentially specifying, right, for each and every attribute of the JSON file, right, what kind of information should be outputted, right? These are all kind of placeholders that you can verify here under the help, right? So for instance here, a name, right? If you take a look at first name, boom, it tells you, hey, it will just generate a name of person name with both genders if the gender is not specified. All right, very easy. Here, as you can see, I'm just keeping things as easy as possible. And here at the very top, you can say, hey, the JSON form file that you need to generate, right? I want something between 150 and 250. Every time you generate, right, the workload, the number of actual document will be different. And the same goes here, right, for the number of products. I'm saying, hey, each and every transaction will be dealing with minimum 1 and maximum 9 different products, right? And I'm just picking the products from an array. Very easy. So let's generate. Once you see everything is generated, this tool allows us, right, to either copy the JSON, download the JSON directly, or just upload it to their server, which is pretty cool. I'm going to take advantage of that. There is a limit of 500 kilobytes, if I'm not mistaken. You can just look at the documentation. But now that it's uploaded, I can just copy the JSON file URL, and now created the snippet for us. So again, this could be automated, but I wanted to keep everything as simple as possible. So what we're going to do, right, we're going to paste this URL right here, and we're going to run a wget. A wget where the downloaded file will be renamed to generated_orders.json. And then the second snippet will be the command cb import, right? The cb import command allows you to import within Couchbase information that is typically stored as JSON or CSV. More, you're going to find all the details in our documentation. For this demo, right, what is interesting here to see is that, of course, we are importing some JSON over a Couchbase cluster, which is the local host. We're going to run, right, this command over one of the data nodes. On the bucket -b, it's the bucket Couchmart, username, password. This -f list tells the cd import command what kind of format, right, you should expect. Just check out the documentation, you're going to see everything. It's very easy. And then what is the actual location of the file to be ordered, right? Generated JSON, and these other options. I want to dive into them. I don't want to give you too much detail. But first, we need to wget, right, the new order. So I can do here, and I just open the terminal. Let me just close the one from Splunk. Yep. And here, let me just clear so we are pretty good. I can just paste this one, right? This is one of the data nodes. So if I hit return, we have downloaded, right, some of the files. And then I can just go, boom, take this one, right, and import this. Now, before I run it, right, let me just do like this. So we have 2169 current documents. I'm gonna just run this one, right? All right, 199 more, you see, they were already generated here. And now just wait for Splunk, right? For the information to appear into Splunk. It should happen in the next 30 minutes or so. Here something was already modified. And we should be seeing, right, some new orders coming up soon. Just give it a moment, it's refreshing. Yeah, probably in the next one, right? But the idea is that every 30 seconds, we are pulling the information from Splunk, from Couchbase, and we're loading this new information within Splunk. And Splunk, it will be just, this one was already updated. All right, the machine outlier detection was run. And you see, it changed. For whatever reason, we just verify, right, the number of machine learning, total orders, new orders right here. And yeah, top grossing products, everything updated. You see, again, it took 30 seconds because this is how I configured the dashboard. So if you have knowledge of Splunk, you can do probably way better than what I did. And if you have some data scientists within your organization, right, here I'm just using an outlier detection over, I guess, the approval and the products, right? So I found 29 outliers. With the new import, these outliers were gone. But of course, with real data, right, we can study real information. And as you can see, all this information is generated randomly. So what else? I hope you like, right, this presentation. This is a call to action for you to experiment with the power of Couchbase as a fast data ingestion tool, and the workload segregation, because here I'm just playing the data scientist, right? And I'm not connecting directly to the Couchbase server over the KV. I'm just waiting for Couchbase to replicate the data for me. And I mean, over this dashboard, we are applying intelligence over live data, right? That information literally landed on Couchbase less than 30 seconds ago, right? And we were able to verify that right away. And I mean, the beauty of this solution is that scales linearly. So yeah, if you need to have stringent SLAs, you know what to do, right? You have the chance to scale linearly. Last thing before I thank you, right, for your attention, is that we're gonna publish a blog post about how we configured this exercise. Again, if you use Splunk, this can be something, and of course, and you already use Couchbase, this can be something pretty handful and handy for you, because I mean, it can get you started with this discipline if you've never done that on a budget. So yeah, I mean, you have no excuse. And if you have any questions, please feel free to reach out to me or to James. I'm gonna be super happy to help you out. And yeah, just give it a try. Really, it's really cool. All right, thank you so much for choosing to spend this time with us, and I hope I will see you soon. Thank you.